Hello guys and welcome back to the Code2Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by the Google developer group site VIT-AP. Now we've completed the first problem of day 18 and let's move to the second problem. This problem is the continuation of the first problem, so make sure that you watch it. You'll not understand this if you do not watch that. So make sure that you watch it, you visit that, and let's continue with this question. So it's similar to the first question. The first question was finding if there is a loop in a linked list or not. And now we have to find the starting point. They're telling us that there will be a loop in the linked list. Just find the starting point of it. And if there is no linked list, if there is no loop, just return null. So we have to find the starting point of the linked list. Starting point of the loop in the linked list. Will be given with the head as the input, and we should find the starting point. So coming to some test cases for this linked list, 1 3 and 4, 3 and 4 are forming a loop. So 3 is the first point of the loop and we should be returning 3. And for this linked list, there is no loop in this linked list, so just return null because there is no loop and there is no starting point of it. Coming to the next one, coming to this linked list, you can see that there is a loop of 2 3 7 2 and 9. Now you have to be returning 2, not this 2, but you have to return this node. So this is why they are asking us to return nodes instead of returning values, right? So if you return 2, it can be this or this. So if we return node, we can only return this node but not this node because both are different. So we should be returning this node, which is in the output as well. So let's come to the coding part. Now this is a medium question. So the previous question was easy one, and this is a medium question. So this is nothing but just what I explained right now. So in this example, you can see that 2 is the starting point of this loop. So let's come to the brute force. Similar to the previous brute force, uh, we should be using a data structure to remember what values we came across. So we came across 3 2 0 4 minus 4 0 minus 4 and we come to 2 again. So as we come to 2, we are seeing that a loop is being formed, and as this is the first node that we are visiting again, just return it. See, this is almost similar to the previous one. We just changed the return statements. Previously we used to return true if there is a link, if there is a what you call loop, or null if there is, or false if there is no loop. Over here, uh, 2 is the first node which we are revisiting, so we should be returning 2. So as soon as you visit a node which is already visited, just return it out. Or if you do not visit any node which you visited once, so return null. So this is the brute force. If you solve the first question, you can easily understand this. So let's come and do a dry run. So 3. So first things first, create a temp pointed towards head. Create a hash set which will be storing the nodes, not the values but the nodes. So while temp does not equal null, just make sure that you moved the temp to the next node. So first things first, if condition, if the hash set contains this node, we visited this node again, we visited this node previously, just return this node, right? We visited it and just return it, so because this is the first node which we are revisiting again, so this will definitely be a starting of the loop. We can return this and we'll have our answer done. Else if this is not visited, we are visiting this node the first time, just make sure that you add it to the hash set and move your temp to the next one. Coming to the dry run, see, 3. Our temp is at 3. 3 is not visited. It is the first time. So add it to the hash set, move to the next. Move to 2. 2 is not in the hash set. Add it, move. 0 is not in the hash set. Add it, move. Minus 4 is not in the hash set. Add it, move. Now you come to 2 again. 2 is in the hash set and this is the first node which we are revisiting again. Just return temp, return 2, return this node. So this is how it happens. So coming to the time complexity, it is similar to the previous brute force. So it will be big of n because we are traversing through the entire linked list. And coming to the space complexity, it will be big of n as well because we are storing every node's value, right? We are storing every node, sorry, we are storing every node. So it will be big of n and time complexity will be big of n as well. So let's try to optimize it by reducing the space complexity. The time complexity will be similar, but the space complexity can be reduced. Let's come to the tortoise and hare method. This is called the tortoise and hare method, and this is used for solving this question as well as the previous one. So let me explain. In the previous question, I mean finding if there is a loop or no. If finding if a loop exists or no, we pointed slow to the head. Similarly, we pointed fast to the head, and we'll be moving slow one step forward and fast two steps forward till fast reaches null or fast's next reaches null. What does this mean? If fast reaches the last node, so we'll be moving fast till it reaches null or it reaches the last node. So slow moves one step and fast moves two steps. In case if fast and slow meet at a point, initially we were returning true, mentioning that yes, true, there is a loop in this linked list. So we were returning true, but here we are asked to find the first starting point of the loop. So just listen for this. I will explain the intuition later. Just listen what is happening. You will be sending your slow to, if they meet at any point, if they meet at a point, just send your slow to head, right? Just send your slow to head. Now, while slow does not equal fast again, while the slow and the fast do not meet each other again, just move slow by one step further and move fast by one step further. So when does this while condition end? When they meet again together. So you should be returning the point after, you should be returning slow, uh, or you can also return fast, because when does this while condition end? When slow becomes fast, when slow equals fast. So it does not matter if you return slow or if you return fast, they both are at the same node and they both will be returning the same node. So first let me do a dry run and then I will explain the intuition. So look at this example. So initially your slow will be over here, your fast will be over here. Now similar to the previous one, slow will be moving to one step further, fast will be moving two steps further, right? Yes. Similarly, slow will be moving one step further, fast will be moving two steps further, right? Cool. Now slow will be moving one step further, fast will be moving two steps further. At this point, both are slow and fast pointers meet together. So the first thing we can say that yes, there is a loop. Yes, a loop exists in this. So yes, there is a loop in this. So we can find the starting point of it. So what did I tell you? As soon as the slow and fast meet, as soon as the slow and fast meet, send your slow to the head. Fast will be over here only. Fast will be at the point where they meet only. Send your slow to head. This is our head, right? This is our head. So send slow to head. Now move slow by one point, one step further, and move fast by one step further till they meet each other again. Now if we move our slow to one step further and fast to one step further, they are meeting over here only. So this is a simple case. We'll do dry run over bigger cases. So they are meeting over here. And what can you see? This is the first point of the starting. This is the first node in the loop. So we can return either, as I told, we can return either slow or we can return either fast. So we can return anything from this, and this will return 2, which is the first node in our loop. So 2 will be returned, which is what we want to return. So finally our answer will be correct. Now let's move to another bigger case. So slow will be over here, fast will be over here. Move slow to one step further, fast will move two steps further. Slow will be moving one step further, fast will be moving two steps further. Slow will be moving to here, and fast will be moving here. Sorry, fast will be moving here. Right. Slow will be over here, fast will be over here. Slow will come to 5, fast will come to 10. Yes. Right. Yes. Slow will come to 6, fast will come to 12. Slow will come to 7, fast will come to 5. So we are over here right now. Slow will be coming to 8 and fast will be coming to 7. Right? Yes, I'm right. So yeah. And now we will find a meeting point. Both slow and fast will be coming to 9. Cool. We found our meeting point. First thing, find the meeting point. Find the first collision point. Next thing, as soon as they collide, as soon as they come to the same node, send your slow to the head. This is a head, right? Send slow to head. Now, what should you do? Just move. See, what should you do? Just move slow one step further and fast one step further. Slow will be coming from here to here. Fast will be coming from 9 to 10. Slow will come to 2. Fast will come to 11. Slow will come to 3. Fast will come to 12. Slow will come to 4. Slow will come to 4. And similarly, fast will also come from 12 to 4. See, they are meeting again over the fourth node or the node 4. So did you observe something? Yes, they did, and at the second collision will be at the starting point. Will be at the starting point of the loop. This will happen damn sure. This will damn sure happen. So they will be meeting at the fourth node or the starting node of the loop, and we can return slow, either slow or fast. So this will be our answer, and yes, it is true. It is correct. Now I hope you got what we should be doing. So slow will be moving one step further, fast will be moving two steps further. If they meet at a point, slow should be going to head. And while slow does not equal fast, just move slow by 1 point and move fast by 1 point. And after they meet, this while condition ends, return either slow or return fast. Now, if they do not meet itself, I mean if there is no loop itself, will come out of this while loop and the null will be returned, which means that there is no loop and there is no starting point. If a loop exists, then definitely a starting point will exist. So let's now come to the intuition or why this is happening. Let's now understand why this is happening. So this will be our starting point. So we want our final answer as 3. Now this I took this example in the previous first problem also. So we saw that both slow and fast will be meeting over here. Initially slow and fast both will be over here. Now imagine your slow is over here. So if slow is 2 steps further, I mean we perform 2 iterations. So slow will move to 2 steps, move 2 steps further. Where will be our fast? So if slow move 2 steps further, fast will also move 2 times, but it will move twice, right? Fast will move 2 steps further. So fast will move like here and this. So fast will be over here. Am I right? If S is at a distance of L, fast will be at a distance of 2L from the head node, right? It will be a distance of 2L. So if we can call this to be L, then this will also be L, right? I hope you are clear till here. Now, this is the required loop, right? If this is L, let's call this to be D. The distance between fast node and the slow node to be D. So what is the entire length of the loop L plus D. Am I right? For now, the length of the loop will be L plus D because we are covering every node and the length is L plus D. Now, where are both fast and slow meeting? They will be meeting over here. I'm right. Am I correct? Yes. Yes, I'm correct. They will be meeting over here. Now, let's look at how many steps fast is moving towards. Fast is moving 2 steps towards the slow, and slow is moving 1 step in the opposite direction. So fast will be moving towards slow and slow will be moving from far away from the fast node. So fast will be moving 2 steps towards slow and slow is moving 1 step away from fast. So after every iteration, see, now the distance between fast and slow is d, right? So after one iteration, fast will move 2 steps. So the distance will become d minus 2. But slow is moving 1 step also, right? So the distance will not be d minus 2, but it will be d minus 1. Because fast is moving 2 steps. So the distance will reduce to d minus 2. But slow is moving 1 step away from far. So the distance will not be d minus 2, but it will be d minus 1. Right? I hope you are clear till here. So where will our fast and slow meet? They will meet here. So what does this mean? Over here our distance or d equals 0. Am I right? Distance between fast and slow equals 0. You should be clear till here. Now I'm going to explain the main step. So for every iteration, the distance between fast and slow is reducing by 1. See, initially the distance was d. After one iteration, it will become d minus 1. After 2 iterations, it will become d minus 2. So after some iterations, the distance, it will reduce from d to d minus 1 to d minus 2 to d minus 3, and it will slowly become 0. When is it becoming 0? In this node. So assume there are d steps. So how many steps are happening? D minus 1, d minus 2, d minus 3, d minus, so it will go to 0. D steps are taking place for both fast and slow to meet, right? So we can say that the distance between the slow and this point will be d. Or let me do one thing. The distance between slow and the d and the point which they meet will be d. I hope you're getting this. I hope you got this. So for one step, the distance will become d minus 1. For 2, it will become d minus 2. So for d steps, it will become 0. And it is becoming 0 over here. So S will take d steps. It will move from here, d 1, 2, 3, 4, 5. It will take d steps for meeting the fast pointer. So finally both S and F will be over here, and this length is d. Now let me draw. See, we know the length of the linked list is d, L plus d, and I am saying this distance is d itself. So what do you think will this distance be? The entire length of the loop is L plus d, and this is d. So what do you think will this be? It will of course be L, right? If the entire thing is L plus d and this is d, what will this be? It will be L. So the fast and the slow pointer both are at L distance from the starting node. Am I right? Are you clear till now? Let me just make it clear for you. Initially, this is the answer you want. This is L. And now I am telling that both fast and slow, will be at L distance from the answer when they meet. So if we send our slow pointer to the head, so only fast is over here. If we move one step further, fast will also move one step further. If we move one step further, fast will also move one step further. And it is sure that they will meet at a point, and that point will be our answer, because both slow and fast are at L distance from our answer. Right, both slow and fast are at an L distance from our answer. So we have to send a slow from here to the head, so that both are equidistant from our answer. And if we move both one step further, they will definitely meet at our answer, and we can return it. So I hope you got this intuition. So let me just summarize everything, and don't worry if you do not get this. Just remember this. Well, you should not remember this, you should not by heart this, you should understand the intuition. Just go back again and listen to it. If you're confused, you will get clarity, trust me. So initially slow should be at head, fast should be at head. Then we should run this while condition uh, till when fast does not reach null or its next does not reach null. So yeah, slow should move one step further, fast should move two steps further. When fast and slow both meet, when they collide, send slow to the head and move both slow and fast one step further. Then they will meet at another point for sure. Return that point. Either you can return slow or you can return fast. Now, do not get confused, but we can also send our fast to head, because both are slow and fast will be over the meeting point. They will be over here, right? They will be over here. Both slow and fast will be over here. So how does it matter if you send fast or slow to here? You will be moving one step further, till both will be moving one step further till you reach the answer. So it does not matter if you send the fast or slow. So don't get confused. For now, send slow to the head and move one step further till they both meet again. Return the point which they meet again, and this will be your answer. Now, if there is no loop, then you can return null. So I hope you got this. Now coming to the time complexity, it will be big of n, as well uh, as we are moving through the entire linked list. I mean, in the worst case, we'll be moving through the entire linked list. So actually, it should be big of see, it will be big of n for finding if there is a loop or no. Finding loop exists or no. Then we'll be sending our slow to the head. Slow equals head. Then it will be another big of n. Just this is the worst case, where the first node, where the head itself is looped. So we'll be sending our slow to the head, and we will be what do you say? We should be moving slow and fast. Both should be moving one step further to meet. So actually, it should be big of nearly big of 2n, but we can write it as big of n. So remember, time complexity is big of n. And coming to the space complexity, it's big of 1, because we are not using any extra space. We are only using 2 pointers for doing everything. And yes, I hope you got the time complexity, the space one, and yes, this is exactly what you need to know. So I hope you got this. This brings us to the end of this problem. So we are done with problem 2. We'll be moving to problem 3. So meet you with the problem 3. Thank you.